All right, let's talk about the quadratic formula. Up to this point, we have solved factoring using factoring, but in some cases, quadratic equations can't factor. And so you can't just give up and say, I can't solve this. You have to use a different method. And so we're going to go over the quadratic formula that works when you can't factor. So to start with, when we are solving, we are looking for those x-intercepts, roots, zeros, solutions. They're all interchangeable almost to find those points. So anytime that we tell you to find the x-intercepts or the roots, we're talking about the same thing. In order to do that, you need to know the quadratic formula. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. That is the quadratic formula. You need to know this formula in your head. You do not get a formula chart, so make sure that you know it. Now, where does this b, a, and c that it's talking about? Well, our standard form of the equation is ax squared plus bx plus c. That's our standard form of a quadratic. And so if we're looking for the x-intercepts, that is when y is equal to 0. So your first step, anytime we are solving, should be to get the equation set equal to 0. And then the value in front of x squared is your a. That's what's going to go in the place of the a right there. The value in front of the x is our b, and it is going to go in the place right there. And then our c, our standalone number, our constant, is going to go in the place of c in our formula. So let's try some. Here is the first one. So we have been learning factoring so far. If I look at this first equation, I multiply negative 2 times 7, and I get negative 14. Well, there's nothing that multiplies to be negative 14 and adds to be negative 3. So this is not factorable. So we need another method. So we use our quadratic formula. I like to put parentheses in the place of the b's and the a and the c because I feel like it helps me with order of operations. So I'm going to set up my equation with parentheses. And so that is negative b plus or minus the square root of b squared minus 4ac all over 2a. In this equation, in front of the x squared, we have a negative 2. So my a is negative 2. In front of the x, we have negative 3. So my b is negative 3. And in my standalone number, my constant is 7. So that's c. So we're going to go ahead and fill in our parentheses now. So negative 3 right there, right there. My a value is negative 2, so it's going to go here, and then my c value is 7, and so there it is. Now, a lot of people will try and do this all in one step. It causes a lot of issues in order of operations stuff, so just don't do it. Go step by step so that you're not making silly mistakes after doing it correctly. So our negative 3 is a positive 3. And then we've got the square root here. Negative 3 squared, that's negative 3 times negative 3, so that is a positive 9. Negative 4 times negative 2 is a positive 8, times 7 is 56. And then in my denominator, we've got a 2 times a negative 2, which is negative 4. So we are simplifying this step at a time. We are now going to add what's under my square root. And so 9 plus 56 is 65 over negative 4. This is a perfectly good answer. You can't really simplify this radical. So this is a perfectly good answer. Now it is telling me 3 plus the square root of 65 over negative 4 and 3 minus the square root of 65 over negative 4. That's what that means. So there are two zeros here, or two solutions, or x-intercepts. If you want to get the decimal approximation, because this is the exact answer, this is a good answer. But if you want to get the decimal approximation, hit alpha y equals so you get a numerator over denominator, and then you can put this in the way it looks on your paper there. So we get 3 plus the square root of 65, and then in our denominator, we're going to put in negative 4. You can't see that very well. Let me put it over here. There we go. And I hit enter, and there's my decimal approximation. I can use my arrow key to arrow up and highlight that and copy it. And so then I would change the plus to a minus. So you are doing two separate ones. That's what this plus or minus is. You're doing the 3 plus square root of 65 and 3 minus. And so there it is at 1.2655. That's the decimal approximation. I want to show you real quick. If I go to my y equals and I put in my equation here, and then I put in 0 for y2. And so we're going to graph this. I hit second trace, intersect, and I move over to my zeros, and I'm going to hit enter, enter, enter to find that intersection. There it is at 1.2655, which is exactly what we just saw right here, 1.2655. And so then if I went back to my graph and I found this one, I would find the other root that we just found, the negative 2.7655. So you've solved by graphing before and found these same exact answers using the calculator. But when you don't have the calculator, you can do the quadratic formula to find it. All right, so let's try another one here. Now, if I was given this and asked to just solve this quadratic equation, I would factor it because this one does factor, and factoring is easier. With the factoring, I need to find what multiplies to be negative 24 and adds to be negative 5. And I'll do that up here just so you can see that. So that's a negative 8 and a positive 3 is equal to 0. And so what makes this 0 is 8, and what makes this parentheses 0 is negative 3. So those are my two solutions here. But we're going to go ahead and do it with the quadratic formula since that's what we're focused on today, so you can see how that works. So I'm going to place my 1 in the place of A. I'm going to place negative 5 in the place of B. And I'm going to place negative 24 in the place of C. And so now we start to simplify. Negative times a negative is a positive 5. Negative 5 squared is 25. And then we're going to do negative 24 times negative 4 is 96. All over 2. Now I'm going to add what's under the square root. So 25 plus 96 is 121. Now we do know this right here. The square root of 121 can be simplified. It is 11. So we're going to do 5 plus or minus 11 over 2. Once I take the square root of 121, there's no more square root here. That's a mistake I see a lot of students do, is put that square root there, but we've taken the square root of 121. That's what gave me 11, so there should be no square root there. Now we can break this up into two parts. So 5 plus 11 gives me 16 over 2, which is 8. And then 5 minus 11 gives me negative 6 over 2, which is negative 3. Notice again, you got the same exact answer. So it doesn't matter if you pick one method over another, you are going to get the same answers, of course, if you do it correctly. But we wanted to show you, we're going to focus today on the quadratic formula. This one here is set equal to 0, so it's ready to go for our quadratic formula. This one here is not. So my first step would be to go ahead and add the 7 to get it to the other side and get it set equal to 0. It always needs to be that way before you start doing the quadratic formula. So if you want to go ahead and pause the video, try both of these with the quadratic formula and see what your answer is, and then come back and check it. There you go. Check your work. You should have plugged in 3 for A, negative 11 for B, and negative 2 for C on this one here. Once you get it plugged in, you end up with 11 plus or minus the square root of 145 over 6. 145 is one that you can't simplify the square root, so you are done there. This is a perfectly good answer. It's the exact value. Again, you can put it in your calculator and find the decimal approximation, but we probably won't have a calculator on the quiz, so this would be your final answer. All right, for the second one, you wanted to go ahead and do the quadratic formula. We did end up with the square root of 36 on this one, so that could be simplified. So we went to 6 on that, and so we ended up with negative 1, negative 7. Hope you got both of those correct. All right, the next thing we're going to do is determine the number and type of solutions for quadratic, and we'll start with that by looking at a graph first. So when we're looking for these solutions, roots, x-intercepts, remember those are all interchangeable. We're looking for that place where it crosses the x-axis. And so we start that by plugging 0 in for the y because that's what makes it a true statement there. So we're going to start with that 0. This does factor to be x minus 2, x plus 2. So if you solve this by factoring, you could find that 2 and negative 2 are our solutions. Well, if we look at our graph, we see that's negative 2 and 2 right here. It crosses the x-axis in two places, so this has two real solutions. So anytime it asks you to determine the number and type of solutions, this is your answer right here. There are two real solutions. All right, when we look at this second one, it has the vertex on the x-axis. We know that the vertex doesn't have a symmetrical point. The axis of symmetry cuts right through it, so it only has one solution. So this would be one real solution. Now this one here does not touch the x-axis, and in Algebra 1 they probably taught you to say no solution for that, but they really should have taught you to say no real solution for that one, because this does have two imaginary or complex solutions. We learned about those last time. That's when we end up with an I because we have a negative under the square root. And so we're going to talk a little bit more about that, but this right here has two imaginary solutions. So these are our possibilities. We can have a quadratic that has two real solutions, one real solution, or two imaginary solutions. Now, looking at it from the graph point of view is the easiest way to determine how many solutions, but you should be able to tell from an equation as well. So let's talk about that. What we do is we used the radicand. And so the radicand is the expression underneath the radical sign. It's the b squared minus 4ac. This tells us a lot about our solutions. It tells us how many and what kind of solutions. So it is called the discriminant. This is called the discriminant. B squared minus 4ac is called the discriminant because it discriminates the number and type of solutions. If your discriminant, b squared minus 4ac, comes out to be greater than 0, so it's positive, then there are two real solutions. If the discriminant, the b squared minus 4ac, comes out to be 0, then there is one real solution. And if it comes out to be less than 0, which means it's negative, then there are two imaginary solutions. So from a graph, we look at how many times it crosses the x-axis, but from the equation, we do the discriminant. And I'm going to show you how that works on these down here. Anytime that it asks you for the number and type of 0, so right here, you don't want to waste your time solving the whole thing to find that. We use the discriminant to find that. So we want to know how many and what type of solutions this has. So we're going to do b squared, so that's 2 squared, minus 4 times my a value times my c value. I don't have to do the whole solving, the whole quadratic formula. That's only if I want the actual solutions. This just wants to know how many. So this is 4, and then negative 4 times negative 3 is a positive 12, times a negative 1 is negative 12. And so that gives me negative 8. We said if it comes out to be negative, it is two imaginary solutions. So my answer here would be two imaginary solutions. All right, we'll try another one. So this one right here. Again, my b squared, so that is 1 squared, minus 4 times negative 1/2 times my c value of negative 1/2. Now 1 squared, that one's easy, 1. Negative 4 times negative 1/2 is a positive 2, times a negative 1/2 is a negative 1. And so that comes out to be 0. We said if b squared minus 4ac is equal to 0, there is one real solution. So this is one real solution. I'll do one more with you. So b squared, negative 5 squared, minus 4ac. That's b squared minus 4 times a times c. That's always what you're doing, the part that's under the square root of the quadratic formula. And so that's 25. Negative 4 times 2 is negative 8 times a negative 6 is positive 48. I add those two together and I get 73. This is positive, so I have two real solutions. Again, if it asks how many and what type of solutions, you're doing the discriminant. You don't have to solve the whole thing. All right, try D and come back and see if you got the correct answer. Pause the video. You should have gotten 169, which gives you two real solutions because it is positive. So positive means there's two real solutions. That's what you should have gotten for D. All right, so we're going to solve a couple more here. This first one, negative x squared minus 6x equals 0. I'm on the test. It says solve this. I'm going to factor. This is a much easier one to factor. They both have an x, so I can factor out my GCF. So if I factor out a negative x here, negative x times x gives me negative x squared, and negative x times a positive 6 gives me a negative 6x. Now, we factor because we want to know what can make either one of these 0, because if this is 0, 0 times anything is 0. And so the first one's easy. If it's 0, then that's going to make the whole thing 0. For the second one, negative 6 plus 6 makes that 0. So there's my other solution. You can go ahead and do the quadratic formula, but this is way easier to do with factoring. All right, now we're going to do the quadratic formula on this one. Nobody really wants to factor with a 1/2, and so quadratic formula might work best here. So negative 4 plus or minus the square root, negative 4 squared minus 4 times 1/2 times 8, all over 2 times 1/2. And again, take it step at a time so that you're not making a careless mistake. The negative and the 4 turns that into a positive 4. Negative 4 squared is 16. Negative 4 times 1/2 is negative 2 times 8 is a negative 16. And 2 times 1/2 is 1 down here. And so we end up with 4 plus or minus the square root of 0. Now, the square root of 0 is 0, so we get 4 plus or minus 0. This is why you only end up with one real solution, because whether I add 0 or I subtract 0, it's still going to be 4. So I have one solution, it is 4. All right, so the one that we've been leading up to is our imaginary answers. I know you're dying to see one of those, so here it goes. We have x equals negative 12 plus or minus the square root of negative 12 squared minus 4 times a times c all over 2a. The negative times the negative gives me a positive 12. Negative 12 squared is 144. And then we have negative 4 times 2 is negative 8 times 19 is negative 152. You can already see what's happening right there. This negative number is bigger than this one, so we know we're going to end up with a negative number in there. So 144 minus 152 is negative 8. Anytime you have a negative under the square root, you have an imaginary number. That's why that discriminant, when it's negative, tells us we have two imaginary numbers. So we simplify the 8 just like we would any radical, like if it was positive, you're going to simplify that like normal, but then for the negative, you have the I. So we get 2I root 2 over 4. The I comes from the imaginary number. 4 is the biggest perfect square that goes into 8, and the square root of 4 is 2, so that comes out here. And 4 times 2 is what gives you 8. And so this is a perfectly good answer. You could leave it like that. If you want to reduce your fractions, you can reduce your fractions. 2 goes into all of those, and so we would have 6 plus or minus I root 2 over 2. There's your imaginary number with a quadratic formula. All right, the last one we're going to do here is we're going to write an equation for the function that has roots of plus or minus 5i. Now, when we write an equation and we're given roots or solutions, remember you're using the factored form. So our equation would be y equals and then an a, but since they give us no other information, it's fair to assume that a is 1. And then x minus my first root, which is a positive 5i, and then x minus my second root, which is a negative 5i, so that's going to turn this into a positive because negative minus. And so here it is. Now we would not want to leave this like this because you have never been given a quadratic that has an I in it. So when we get this to the standard form, we will lose that I. Just like when we learned when we were doing the operations of complex numbers, we know that when we have the difference of two squares, our middle term are going to cancel out, so we're not going to have an I. But let's do it so you can see. X times x is x squared. X times 5i is 5xi. Negative 5i times x is negative 5xi. Negative 5i times a positive 5i is negative 25i squared. Now, these are the same with a different sign, so they're going to cancel out. And we know that I squared is negative 1. So negative 25 times a negative 1 is a positive 25. There's our equation. Told you there wouldn't be an I in it. All right, that's quadratic formula.